Welcome to my new channel, Maths with Lily. This is my first video that I'm putting out. You're probably here because you need help with your maths, and I'm here to help you. Today we're going to get started with exact trigonometry. Essentially, if you've got any other topics that you want me to cover, please leave me a comment below. I'm taking requests. Any questions that you want me to go through and you need help with the answers, please just let me know. Now obviously everyone in the UK is doing school from home. I just thought this would be a really helpful resource for people to have out there. So if you want to see more content, then please like this video, share this video, subscribe, and I will put some more content out there for you. Today we're going to be looking at the GCSE topic, and this topic is exact trigonometry. So I'm going to show you two triangles and how you can use these two triangles to answer some questions about exact trigonometry. So the first triangle we're going to look at is an equilateral triangle. We're going to take the side length 2. Triangles have 3 angles that add up to 180 degrees, and it's an equilateral triangle, so all the angles have to be the same size. So 180 degrees divided by the 3 angles is going to give us 60 degrees per angle. What we're going to do with this triangle is we're going to just chop it in half, which means this angle here at the bottom is a right angle, and this angle here we've divided into 2, so this side here is going to be 30 degrees, and this side length on the bottom was 2, but we've divided it by 2, so now we've just got a side length of 1. We don't know what this side length is here actually, but we can work it out. We're going to use Pythagoras' theorem. So a squared plus b squared is equal to c squared. So the two shorter lengths squared add together to be equal to the hypotenuse squared. So a squared here is going to be 1 squared. Add b squared, which we don't know. And this is equal to c squared, and we know c is 2. So this is going to be equal to 2 squared. So we've got 1 plus b squared is equal to 4. And b squared is equal to 3. Taking off 1 here from each side. And now we know if we take the square root of both sides here, we're going to get b is equal to plus or minus 3. However, it's a side length, so we have to take the positive one. So we know b is equal to the square root of 3. So you might be wondering now, what is so special about this triangle and why am I talking about it? So with exact trigonometry, you were going to have to find out sine of 60, let's say, or sine of 30, or cos of 30, or tan of 30. And believe it or not, with this triangle, you can answer all of those questions. We know from SOHCAHTOA, sine of an angle is equal to opposite divided by hypotenuse. Cos of an angle is equal to the adjacent divided by the hypotenuse. And tan of an angle is equal to opposite divided by adjacent. If we look at sine 60, this is going to be equal to the opposite divided by the hypotenuse. So looking here from the angle, the opposite is going to be the square root of 3. And the hypotenuse, which we're dividing by here, is going to be 2. So we worked out here that sine of 60 is equal to the square root of 3 over 2. Now, that's pretty cool that we've managed to work that out. And from this triangle, we can now go ahead and work out what cos of 60 is. So, cos of 60, coming from here again, is the adjacent divided by the hypotenuse, so 1 divided by 2. And tan of 60 is equal to opposite divided by adjacent, so that's just root 3 divided by 1, which is just the square root of 3. So the next thing we can look at is sine, cos and tan of 30 degrees. So sine of 30. Sine of 30 is opposite divided by hypotenuse, so that's also a half. So you notice here, cos of 60 is equal to a half, and sine of 30 is equal to a half. Cos of 30 is equal to adjacent divided by the hypotenuse, root 3 over 2. again, cos of 30 here is the same as sine 60. And tan of 30 is equal to opposite divided by adjacent, which is 1 over root 3. Cool. So the next triangle we're going to look at is an isosceles triangle. Two side lengths of 1. We don't know what this side is currently. We know this has got a right angle here. And again, 180 degrees for all three of the angles. We know this is 90 degrees. So we're left over with 90 degrees here. So we know these two angles add up to 90 degrees. It's an isosceles triangle, so these two angles are going to be the same. So 90 degrees divided by 2 equals to 45 degrees. So this is 45. And this one is also 45 degrees. And now what we need to do is we need to work out the last side length here. So we're going to use Pythagoras again. A squared plus b squared is equal to c squared. In this case, a is 1 and b is also 1. And the hypotenuse is going to be equal to c squared. So we've got 1 squared add 1 squared, so this is just 2. Now again, taking the positive square root of 2, c is equal to the square root of 2. So now if we look at the sine, cos and tan of these angles here. So sine of 45. Sine of 45 is opposite divided by the hypotenuse, so that's 1 divided by root 2. Cos of 45 is also going to be adjacent divided by the hypotenuse, so that's 1 over root 2 as well. And tan of 45, oh, not 4, that is equal to opposite divided by adjacent, which is just 1 divided by 1, which is 1. Now we've learnt about these two triangles and how we can use them to work out exact trigonometry. Let's look at an exam type question. So we've got a triangle here and it's got angle here of 60 degrees, angle here of 30 degrees, and we've been asked to try and work out this side length here, which is x. We know the hypotenuse is 10 plus 2 root 3 in length, so that's a good start. One thing that we should now think about is the triangles that I was just telling you about. So do you remember that there was one triangle which had an angle of 60 here and 30 at the top there? Yes, so that was the first one that we looked at, and we looked at an equilateral triangle 2, 2, 2. So this one is 60 degrees and divided by 2, so this has side length of 1. And this was 30 degrees. They look pretty similar, don't they? All the angles are exactly the same. This is just a larger version of this triangle. So how have we got from this triangle to this triangle? Well, it's been enlarged. If we just factorize this quickly. So 10 plus 2 root 3. Well, this is just equal to, let's see how many multiples of 2. So we just take 2 out as a factor, which is what we want to show here, the enlargement. And then we're left with 5 plus the square root of 3 here. So what we've done to get from this triangle, which we've learnt about and we know about now, to this triangle is an enlargement of 5 plus the square root of 3. So that's what's happened to all the side lengths in this triangle to get to here. So to work out x, we need to multiply the 1 here also by this scale factor enlargement, and that's going to give us x. So 1 multiplied by the scale factor here, which is 5 plus the square root of 3, which any number times 1 is just itself. So we're left with 5 plus the square root of 3. And that is your answer to that question. So the next question that we're going to look at is also from another exam. Here we've got a triangle, 5 root 2 as the hypotenuse. We're trying to work out x here, but we know that this angle is 45 degrees. This is a right angle, therefore we also know this angle here is 45 degrees. So again, if we look at the angles here, they're exactly the same as the second triangle we looked at. before. So do you remember it? It had, it's an equilateral, 1, 1, and this was the square root of 2. 45 degrees here and 45 degrees there. Okay, so to get from this triangle to this triangle here, we've got another scale factor of enlargement. And you can see here, this triangle has been enlarged by a scale factor of 5. We've gone from root 2 to 5 root 2. So we can go from 1 to work up this x here. And we know the scale factor of enlargement is 5. So any side here needs to be multiplied by this scale factor to work up the answer. So we know that x is equal to 1 multiplied by this scale factor 5 here. And that is your answer. Thanks for watching my video. If you found it helpful, please comment below with any other topics you'd like me to run through, and subscribe to my channel, that would be great, and like and share this video. Thank you.